Just a quick how do you do Jamovi for a t-test or for your data. You double click in the variable name and you give it a name. Let's say participant code. That's nominal. Leave it nominal. Then I double click this and I'm like, okay, my condition code, that's also going to be nominal. I double click this. Question 1. Double click this. I have to make a choice. New data variable. Question 2. Double click this. New data variable. Question 3. All right. And then I double click this. New computed variable. Formula. I'm going to call this average scale. That's the average of question 1, 2, and 3. That is going to equal question 1 plus question 2 plus question 3. If you notice, I clicked the little function button. I just plopped my 3 questions in there and divided by 3. Now, if one of your questions is negatively worded, let's say question 2 this is going to be a 5-point scale. If I add 1 to the scale, generally this works if you start with 1. There's different math, but let's say you have a 1 to 5-point scale. 6 minus the question will reverse score your score. All right, so what does that do? 6 minus 5 is 1. 6 minus 4 is 2. 6 minus 3 is 3. 6 minus 2 is 4. 6 minus 5 is 1. You see what I mean? Or 6 minus, 5 is 1. So that's how the math works. Now, if you have a 0 to 5 scale, like if your scale starts at 0, you just take the max scale of the score. 5 minus 0 is 5. 5 minus 1 is 4. 5 minus 2. That'll reverse score for you if you start at 0. If you need help figuring out your formula, let me know. But I got question 1 plus reverse item 2 plus question 3. That's going to be my average scale, okay? So let's just see how I entered data in there. Participant A, condition, control, 1, 5, 1. Does the average for me. Participant B, they're in the experimental group. Question 1, let's say they were 5, 1, 5. You kind of see what I'm doing here. Participant C, they're in the control group. 2, 4, 2. See how it's all a 2 there? See how it's all a 1? I'm proving, I'm just showing you this. Participant D, they're in the experimental group. And they got a 4, 2, 4. All right. So now, when you run your t-test, which is all you have to do, independent samples t-test, I've got my condition code. I've got my average scale. I've got my effect size, 95% confidence intervals. Might as well have my descriptives and descriptive plots. There is no big deal here. What did I find? Oh, this is non-significant but close. So, my T statistic is 4.242. My degrees of freedom are 2. My p-value is 0.051, greater than 0.05, non-significant, inconclusive. My effect size is large, but my effect size could range from large in the direction I found, because both these effects, they represent the direction I found, which was experimental higher than control, right? Could range from large in the direction I found to medium in the direction I did not find. Means and standard errors for your tables on your standard deviation, mean, and the plots. This really isn't that hard. What do we got here? You'll see T. That's what I write down first. Put that in parentheses. I'm sorry, in italics. Then I put in parentheses 2 for my degrees of freedom. Equals negative 4.24. That's it. Don't add more numbers. All right. Comma P less than 0.05. Comma D equals negative 4.24 with 2 brackets, negative 9.77, comma 0.74. End of the bracket. Okay, that is it. The independent samples t-test testing the difference between control group and experimental group, which was predicted to be positive such that the experimental group had higher means than the control group. I put the mean and standard deviation in there when I state that, was not supported, and but however the data are inconclusive because our p is greater than 0.05. All right. That's where we're at. That's all we do. We are done. This is how you do a t-test. Good. This is how you enter your data and do a t-test.